Alright, hi. Welcome to the fourth problem of the series. Again, I'm going to be solving this question with you all. So, a point moves rectilinearly in one direction. So, the intention behind this line is that distance and displacement have the same meaning in this question. Since the particle is moving in one dimension and that also in one particular direction, it just means that velocity is equal to speed, so displacement and distance have the same meaning. So this is not only a distance time graph, this is also a displacement time graph, right? Displacement time graph. So for the first part, we need to find the average velocity of the point during the time of motion. So as has been discussed earlier in a lot of videos, V average is nothing but total displacement vector, right? Total displacement by total time. Now, total displacement in this case is nothing but total distance as we discussed earlier, which is nothing but 2 meters, and total time is 20 seconds. So this is 0.1 meters per second. So the answer to part A will be 0.1 meters per second. So this is done. For part B, the maximum velocity is what we need to find. So what is velocity? Now for part B, we know velocity at any moment v is nothing but ds by dt, which is nothing but tiny nudge in displacement divided by tiny nudge in time, right? Tiny nudge in time, which is nothing but the slope of displacement or distance time graph, in this case slope of graph. So we need to find the maximum slope, correct? Now if you observe the graph carefully, from this point to a point somewhere over here perhaps, the graph appears to be a straight line, right? Because if I try to insert a straight line, not quite sure if I can, but the point is, if you look at it, this appears to be a straight line, and this straight line is also the one with the highest slope that you can get anywhere in the graph. Because if I draw a tangent over here, its slope is less than slope at any point in this region, right? Because at any point the slope of that line will just be this line itself, because the velocity is apparently constant between points A and B, correct? So if you look at इधर का slope, everywhere the slope is less than the slope of AB, so AB has to have the maximum slope and thus the maximum velocity. So maximum velocity is nothing but since we can use advantage of the fact that the velocity is constant in AB, so you can still write total displacement by total time instead of ds by dt. So total displacement, if you look at the scale of the graph, this has to be 0.2, 0.4, 0.6, 0.8, 1.2, 1.4, correct? So the height is going to be 1 meter, and this is going to be 12, 14, 16, 18. So the width is going to be 4 seconds, right? So the slope is going to be 1 meter by 4 seconds, which is 0.25 meters per second. So that is the answer of the second part as well, 0.25 meters per second. Now that's done, we move to the third part, the time moment t at which the instantaneous velocity is equal to the mean velocity averaged over the first t seconds. So let's try to get a feel of what the question is actually asking, the third subpart particularly. So what it's saying is, at any time interval t, let's say this is t naught, the time moment t naught at which the instantaneous velocity is equal to mean velocity average over the first t seconds. So if you look at it, the mean velocity over the first t, this is t naught seconds, is going to be this line ka slope, because this is the total distance, that's the height, and the total time is nothing but this axis. So this rise over run is nothing but slope, so this comes out to be OA, correct? And if you look at instantaneous velocity of the particle, this will be a tangent to the curve, as has been discussed earlier. ds by dt is equal to v instantaneous. So we want to find a time interval t naught at which the tangent and the origin, दोनों origin से connecting line to that point का slope is the same. So if you look at it, we essentially need to find a tangent to the graph from the origin. So that will be somewhere, pardon my drawing, that will be somewhere over here, correct? So this time interval is what we need to find. This is again 12, 14, 16. Therefore, T naught has to be equal to 16 seconds. Hope that makes sense.